Ting, the new way everyone is getting their cell service. No overage penalties, great rates, keep what you do not use, no contracts, and someone will actually pick up the phone when you need support. Use our link and get $25 off your first month's service or your new phone. Just go to tech-zen.tv/ting to save $25. Hello, it's Monday night, and it's a few minutes after 9 p.m. on the East Coast. That means it's time for another Let's Make It. And this week, I think I'm going solo again. I'm letting the Skype machine on in case Bob calls in, but his family emergency has been extended a little bit. And I haven't heard from him today to see how things are even going. So that, I don't know if it's a good or a bad thing, but we wish him the best, him and his family the best with all the stuff that's going on with them. So, since we're not going to have the Rainbow Arduino again probably this week, because I know I don't want to put any kind of pressure on him. I want him to take care of his family. That's the most important thing. I have come back, and actually what I was going to talk about tonight, I kind of got sidetracked a little earlier today. As I've mentioned in the past, I'm working on this physical switcher, and I actually met with the people who are going to be doing the designing. And the part that I was going to show you tonight, they kept so they could do some measurements with it. They could figure out what kind of holes or anything need to be cut. So I do have other ones, and I tried. Actually, if you come over here, you can kind of see before 9 o'clock. I was trying to make another one, but I literally walked in here with this thing still warm in my hand at 9 o'clock, so I haven't had time to put it together. But what I was going to show you tonight are some smart buttons, and actually I have some more of those around here. I'm going to show you each one of those that I'm kind of messing with. But this board will hold two of them, and I was going to show you one or two of them. One here, the one they have has two on it, but I have another one sitting here. I just haven't had a chance to get soldered. But I do have something else I wanted to show you that I did this past weekend, and it was one of those little project things where I think it would be kind of interesting to talk about as well. But I want to talk about some of the other parts that are going to go into the switcher, and I'm going back here tomorrow as well, so I'll take some of the stuff back with me tomorrow. Hopefully they're done measuring everything and get it all back. So anyways, this is just a smart button board, holds two smart buttons, and the way these two smart buttons work, it's through SPI, which means you have to tell it which one is the active one. So that's a subject for a different time. But I do want to go through a few other things today as well, and I want to show you the project I made this past weekend. I did something I threw together on Saturday. I don't have a screwdriver to take it apart and show you, but I can tell you what it is for the most part. We'll walk through the code. It's something we talked about before, but it's finally put into a practical use. So before we go too far though, a while back, a few weeks ago, we mentioned about doing electronic things for Halloween. Unfortunately, we haven't heard anything from anybody about the kind of fun projects you do for Halloween. So I still would like to see that. If you do something with electronics and it's Halloween, take a video or picture of it and send it to us, and we'll make sure it comes on the show. So don't want you to forget about that, but nobody come up with any ideas for us things to work on. So this coming week, I am going to see if I can convince maybe my wife to cut out a pumpkin head for me and a few other things, to do some things with electronics, and we'll, next couple weeks, maybe talk about some fun things to do for Halloween. I really don't participate much in Halloween normally, but I think it's going to be a fun project for things to do, and it'd be good to put some things together. Again, if you have ideas, please let us know if you have ideas for Halloween stuff. And if you do something, I'd like to put that on the show as well. You can send it to us and let's put it on the show. A few housekeeping things. This show is recorded live every Monday at 9 p.m. Except for last week, we didn't do it on Monday because it was a last minute thing with Bob's emergency. And so we didn't do a show. I did it later in the week. So I'm sorry if you were here at 9 p.m. to watch us live. We just weren't here at 9 p.m. because we didn't really have any content. And I was going to skip the week, but then I thought, well, I don't want to put an empty week in the schedule if I don't have to. So I did record it later in the week, and you can go back and you can watch that. But normally it's every Monday night at 9 p.m. or right here at Tech-Zen TV. And you can come watch us live, and you can normally chat with us live. Except for tonight, something's wrong with the chat room, and I didn't realize that until I get ready to start the show. So when I went to log into it, it just wouldn't let me log in. And my screen, I didn't know was frozen like it was. I just figured nobody was on the last two shows, and it wasn't talking. So anyways, there is that. Also, if you want show notes from this show or any previous Let's Make It shows, you can go to techzen.tv, or you can also just go, as a shortcut, go to letsmakeit.tv. It'll take you right to the right place inside of the Tech-Zen TV website. Also, if you're on Facebook, you can follow us on our fan page, and we definitely appreciate if you go out there and click follow and spread the word a little bit about us. If it's facebook.com/TechZenTV, and just, as soon as you hit the like button, we try to get those like counts up more and more all the time. And if you use Twitter, we're at TechZenTV, or make sure you use the hashtag we're talking about this show of # Let's Make It. And you can also subscribe to us on YouTube. So you go to youtube.com/TechZenTV. Definitely appreciate you hit subscribe out there if you're watching us on YouTube. You can also get all of our downloads automatically and everything from many of the podcast directories, iTunes, Dogcatcher, whatever you use to watching your podcast. Plus we're on Roku and TiVo and a bunch of other places. Anywhere you can find us on a podcast, you can probably find us. And if you can't find us, let us know. We'll make sure that we show up there. All right, so all the housekeeping stuff is out of the way. All right, so first of all, let me talk about some of the parts that are going to go into the switcher, because there's a couple things that I haven't talked about before, and I'm going to go over here and I'm going to show you one of them. First of all, this is the project. We'll talk about this after the break. And so this is a T-bar control. Now, some people call this a joystick or a T-bar joystick. They're very hard to find, actually, if you go search on the internet by keywords, but this is one by APEM. There's a couple of companies that make them, but this is actually, it's very smooth, and it has 3 pins. It has 5 volts, it has ground, and it has signal. The middle one there is signal. So this is actually not a resistive. The best way I can explain that this works is this is called a field effect. So basically, it's a magnet going back and forth. There's a sensor in there that can tell how far away the magnet is. So by moving that, so there's no actual resistive technology inside of it. And I'm not quite sure what they're doing to get this pin out, but it acts exactly like a not an encoder, but a rotor. A fader, like a regular fader. So it goes from 0 to basically 10K, and by moving it back and forth. But it's all using the field effects, so it's all magnetic based, and it's really, really smooth. I can't really demonstrate how smooth. It's really soft, and you just push it real lightly, and it just goes. So this is a T-bar, and it's using video control surfaces to switch from one to the other. And our one control surface will have this in it. Our C200 product will have one of these optionally in it, and the C300 will have it by default, standard feature. Anyways, I thought it'd be kind of interesting to show you what that is. Again, it is not easy to find. I had a hard time finding the first one, and after I figured out what they were calling it, it made it a little bit easier to find the other ones. This company calls it a T-bar joystick, but searching for T-bar on the internet gets you a bunch of things, not necessarily something that you're looking for. So we talked about rotary encoders before. This is a rotary encoder board. There's 2 of these on here. And part of our wiring scheme, which I'll probably go back at some other point in the future and show you the wiring scheme inside the switcher, because it really is one wire, one bunch of wires that goes across and runs from board to board to board using SPI. And you can these 2 encoders are on the same SPI run. It's 8 wires on a ribbon cable. Basically, it runs from place to place to place. So it's very clean inside. But this is a dual encoder board. You can see the encoders. These are basically push button encoders. So they go in the board for tomorrow. So the other thing that I wanted to talk about this week, let me go ahead and get them out of the bags and everything here that I have, is these smart buttons. So these are from NKK. Now I have found other ones now. I'm trying to get some samples of them. And let me do here so I don't get them all mixed up. This is actually not the one we're going to use, but very, very similar. Let me go here and I can show you, put this over here. And this is a smart button. So this is a LCD display. The background is 2 color. I think it's either red or green, or a red and green combination, whatever you want to do. I think it's like 64 different colors you can do with this particular one. But basically what it is, it's a little LCD display on top of a button. And a typical NKK button. It has a nice feel to it. So NKK buttons are pretty nice. If you look on the bottom, you see these 2 pins right here. These 2 pins are the button contacts. And then on this other side, you see about, I think it's, is it 9? No, it's 11 pins on this side. So this one works a little differently than the one we're going to use. When we're going to use, actually, we talked through it through I2C. Or I'm sorry, SPI. This one is actually more closer to a shift register and how it works. So you can have a bunch of these in series, and you send the data down through the Siri, where SPI I turn on a pin saying you're the active one, then I send you the data over SPI. So this is more like what we've talked about in the past of a shift register. This is 64 by 32, so you basically have 64 dots by 32 dots. So you got to remember that when you're doing the shift register of where that data goes. It's a little bit more complicated, I think. Shift registers are pretty simple until you start adding up a bunch of these buttons together with 64 lines. 64 dots by 32 lines. That adds up really quick to how much data you're sending across. But it's a really cool switch. It has a nice feel to it, and it's just a different way of interfacing with it. So that's that one. And let me go grab another one here. This is another one I don't think we're going to use either. Actually, okay, so let me explain this one. This one's actually not a button, but it is a display. And it's exactly the same ones we just had, but this is a little display only. There's no button attached to it. So this is what's on top of the button normally. But what we have here is just a physical display where you can have it mounted above something and you can do a display. Again, it's 64 by 32 dots, so you can do a little display. I believe the same backlighting as the other one as well. I think this is exactly the same as the one we just had out, except for it's a display only, no button attached to it. All right, so, and then I have two more smart buttons. One we're actually going to use, and then another one that I'm thinking about using on our C300 switch, which is the higher end switch, or one of the higher end switches. Oh, you know what? Sorry. I just realized I never showed this to you. So there we go. That's what it is. That's the display. Same as the other button that we had. Just like that. And the bottom are all the pins that you can put a ribbon cable on, or however you want to attach to it. One thing I'm not sure of is exactly how you would mount it. So I would almost think that to mount this, you'd probably have to build a board to snap it onto. So instead of using a ribbon cable, you would actually, put this into some kind of plug on the board. So I haven't figured that part out. I am looking at these as potential above each individual section or button to describe what the button is, because on our larger boards, we want to make it more virtual, so you can pretty much rearrange it kind of on the fly. All right, so let me get the next one. And just so you know, these things are not very inexpensive. Actually, not cheap either. They're built really nice. If you look at cheap as being something how it's built, but they're built very nice. All right, so, and just to give you an idea, the first button I showed you, I think went for $50-some a piece or something like that. Again, not super inexpensive. All right, so this is the one that we're going to use. And you can see it's very similar to the very first one from look at from the top. Again, you have multiple choices for colors on the back. If you look in the back, you see 2 pins, and if you look at the rest of it, you see 6 pins, which is SPI. So you have MOSI, MISO, clock, and the 4 pins for SPI, and then you have a select saying I am the selected one. And then you also have your power and your ground. There's one more pin left, but I can't remember what it is. And then these 2 are just contact closure when the button pushes. And it feels just like the other one. One thing you'll notice is probably this one's a little bit more compact than the other one. They call this the compact. And actually, if I set them side by side, and then grab the other one out to put it away, and you'll be able to see the compactness of it, which is part of the thing that we liked about it, because it definitely saves some space. Again, it's the same size. No, wait, this is smaller. This is different dot pitch. This is a smaller dot pitch than this one. So there you can see them kind of side by side. So this is the one that we're going to use, and this is the larger one. So it is smaller dot pitch. I can't remember what it is. Is it 16 by 32 maybe for this one? I think it's half the size of this one right here. But anyways, you can see the difference in the compactness. So while we can do sitting there, let me show you the other one. which is very interesting to us. Again, the cost on this one's much higher than the other. And I'll stick it right there. So you see it's the same size as the other one pretty much, but the difference is this is not LCD, this is OLED, so it's full color, and you can put images, pictures, whatever you want in this one. The cost of this one's like $20-some more than the other ones, so it's a little bit cost prohibitive unless you really want to make a high-end board. And we definitely might look at this as an option. Again, this is SPI, if I remember correctly. Yeah, so it's the same number of pins as the compact. In fact, I believe if you look at the bottom, I think you can put one in place of the other, with the exception of there one's a little bit wider than the other. So we could make boards that would have, you know, 2 different switch pins, but the same set of pins for this and different holes, and we could pretty much interchange them as long as we have space for that. So that's something we're going to look at doing. But this one here is full color, and this one is backlit different colors, and it just says this one is as well. So those are the smart buttons. This one I was going to show you was one of these compact ones, because that's what our boards are designed for, these compact ones. And I was going to show you that working tonight. But unfortunately, the one that I have working, these actually go on here, so you can't really see exactly how it fits, but it basically fits like that. And you can put 2 of these on this one board, and this actually goes horizontal, like so, just like that. And you put 2 of these on, you can up to 2 of these on one board, and you can make it do things. So the one that was functioning, I took with me, and they still have, and I'll get it back hopefully tomorrow. So maybe for next week's show, I'll have it ready to go, and I can show you some of the things that we do with it, because it's really neat to have a button that's dynamic like this. All right, so right now I'm going to go ahead and I'm going to take a quick break. We'll be back in a minute or 2.
You work hard for your business. Your website should too. No matter what industry you're in, select your customizable high-quality design with professionally written content and graphic elements created for your business. Make changes online whenever you like. Switch your background color, page layout, and text anytime. Add your pictures and logo. Upgrade your website with useful one-in-one web apps. And integrate social media. Upload your photo albums and embed videos. With one click, optimize your website for viewing on mobile devices. Choose your free domain, or you can easily transfer an existing one. Thanks to One-in-One's SEO tools, customers can find you everywhere. One-in-One My Website, a professional website created by you.
When you open up an Audible audiobook, it opens up your imagination. Enjoy a steamy romance while ironing the sheets. Discover an historic battle while battling the bulge at the gym. Visit audible.com/freebooks now to try 2 books absolutely free. Get caught up in a whodunit during a do-it-yourself project. Listen anytime, anywhere with the Audible mobile app. When you're out for a walk, learn how to climb the corporate ladder. Or bring a little magic to your minivan with a fantasy novel. With over 100,000 titles, Audible is an amazing experience that you can now try absolutely free. And just like our books, there's no binding. Our Great Listen Guarantee lets you exchange a title you don't like for another. No questions asked. Visit audible.com/freebooks to download 2 books of your choice right now.
All right, we definitely want to thank our sponsors, and we had links at the bottom down there, and if you didn't get them, you can always go back to the show notes, or we also have a section on our webpage that talks about special deals, and you can go there and click on the links to get the discounts and everything from the sponsors. And we definitely appreciate our sponsors helping support Let's Make It. All right, so this past weekend, I actually on Saturday had this idea of I do once a month. I do run sound for this kids program, and it's scripted, so we have to pay through the script. You know when the sound effects are coming up and all that stuff. And in the past, we've always used paper and scrolling through the paper. The problem is you can't see what's coming up, so I had this idea of putting it into a PDF, so I could just scroll up and I could kind of see when the page break was, what was coming up. It works. That worked very well. But I didn't want to have to scroll or have my hands on the soundboard all the time. So I was trying to figure out what I was going to do. And I originally was going to do a MIDI interface from the soundboard because I'm running an X32, and I could do a MIDI interface, and I could use the buttons and then go to control and control the screen. Instead, what I ended up doing is we now have all these different button boards that we use for the broadcast things. Some of them are just shields. And I took one of those shields and attached it to an Arduino Leonardo, which can emulate a keyboard, and I programmed it to basically be able to scroll up and down through a PDF file. So I'm going to show you that real quick. This is the board of the box that I created. It's a tiny little box, and actually the box is much bigger than it needs to be for the buttons because the actual shield ends like right here, but it was the smallest one that I had. And actually this fits, if you don't know what X32, they have an iPhone area or a phone area where you can put your iPhone and stuff. This fits right in there perfectly. So it was the perfect size to do that. And you can't, it's hard to tell, but I think it's some of the light off of it. The top button's red and the bottom one's green. And that's just because this is the one that goes forward in the script. And when you push the button, it goes yellow just to tell you that the buttons are pressed, either one of them, and you go either way. Now what you don't see is on my computer, now I'm paging up and down or scrolling up and down through the program that does this. So I want to walk through this program. And we've talked about keyboard control before, and I'm going to show you what I'm doing with the color of the lights and everything as well, and it's easily adjustable. But the other thing I'll do is when it first comes on, and you have to be, let me upload this and see if you can actually see this or not. Let me get the right board, Leonardo, and I think this is no, I can't tell what's the right board and what's not, so I'm not going to upload it. But I'm going to unplug it, and you can see what it does when it comes on. It goes through this little dance. I call it a dance, and that was just for me making sure I had the right colors and everything in the programming. So I could probably take it out now. It doesn't really have any functional things. Yeah, it's just going red, green, red, green. There's no functional reason to have that in there. It was just for me when I was debugging it. So let's do this. Let's hop over to the code. All right. So I actually don't have many comments in here. Originally wasn't intending to really put it out there in public, but I don't mind putting it in public. So this button board that we have in here is one that we created for broadcast buttons for doing other tasks similar to this. We use it something similar to this one that's a little bit bigger to control the soundboard in the studio here. So like if I have to cough or something like that, I can hit the button and it'll mute me. And then I have other things that can mute the audio subgroup of us, so that if we're running commercials, whatever, we can talk to each other while commercials are running. So we have many different styles of boards now that work with both the Mega and the non-Mega series of Arduinos. So the reason it says button 1, 2, and 3 is just like a generic thing that I figure I can use it for other things. Because you can do 3 buttons, and there are about 5 different layouts. In this case here, it's button 1 and 3, which is like in the middle. So I could put like 1 and 2 on side by side, and 3 in the middle or on the other side, or 3 on the top and 2 on the bottom. So I mean, I can mix up like about 5 different patterns you can use across the 3 buttons. So you see I'm using pins 2, 4, and 7 for these buttons. And the reason I did that is because these other pins are I can dim them using PWM. So I wanted to reserve the PWM pins for the LEDs. So that's why it's in a weird, it's not like 2, 3, and 4, because 3, for example, can do pulse width modulation. And the reason that there's no 5 or 6 is 5 or 6 can do pulse width modulation. So that's why it's oddly numbered like this. All right, so here we have our pins for the green and the red for button number 1, the green and the red for button number 2, and the green and the red for the button number 3. These broadcast buttons have 2 LEDs. They are red and green. So there's red and green. If you turn them both on together, it makes yellow, or like a yellow. And then we set next pin, which I don't remember what that does. I Actually, I don't think it's needed anymore. Let me look down there. It's not needed anymore. I took that out, what it was doing. So then we define an array of lights, and that we just do button 1, green and red, button 2, green and red, button 3, green and red. And this is just so we can loop through it nice and quickly on down here, and you'll see why we use that. We define our pin modes, button 1, 2, and 3, as input pull-up. So basically when the button is pressed, it goes to ground. So if we pull them up, it's going to be true until the button is pressed. So you got to remember, when you look at the digital read, you got to say not digital read for it to be pressed. It's something important to remember. Here's why we use the array. So I could basically go through all of the different lights and set them to output. I begin the keyboard, and then the startup cycle is the blinking lights that you saw. That was mainly me knowing that it was working, plugged in properly, and the buttons were working properly. So it's kind of like a little bit of a debug cycle in the very beginning. I could comment that out. It does not do anything functional in any way. All right, so we're gonna go down and we go into our loop. And in our loop, we're going to check button number 1. And if button number 1 is pressed, which means it's not digital read, then we turn everything on, which basically makes 2 yellow buttons. And we keyboard press key up arrow. So button 1 is the red one, the top one. And if button 1 is not pressed, then we go and say, is button 3 pressed? And if it is, again, we turn everything yellow to say that we are going, that the buttons are pressed, and we key down the arrow key. And if neither one is pressed, then we say, okay, we want to send no more key presses, and we want to turn everything off, and then I want to turn red on the button number 1 on, and I want to turn green on button number 3 on. So basically I'm turning off all the LEDs for all the lights and only turning on the ones that I want at this point. Now, here's what's going to be kind of backwards, is we are putting these low to turn them on. So the reason we do that is they were using the pins as an open drain. So the way that the switches work is they have a common positive pin and 2 individual output pins or negative pins that control the LEDs. So to get them to turn on, we got to turn the pins low on the Arduino so that the power is drained through those pins. When they turn high, the LED turns off. So that's why you see turn all on. We actually wrote up a routine to turn all on, which it's kind of backwards. If you go look at turn all on right here, we're actually turning it low, which would you think in your mind would be off. So that's just something to kind of keep in mind. So then I also delay 100 milliseconds because if I didn't, it would go really fast. For me, 100 milliseconds is about right. I could probably make it a little bit shorter, like maybe 80 milliseconds. That would be probably about the right scrolling, but 100 worked fine. So I'm not going to mess with it. Probably just leave it just like it is. And then we go down here to startup cycle, and you just see all we're doing is we're cycling through all the different pins. Oh, there's the next pin right there. So we're cycling through all the pins and just turning them on and off as we go around. So we're not even looking at individual buttons. We're just looking at the actual light pins themselves. So we had defined 6 different LED pins up top, and we're cycling through all of them. I believe with 25, so we basically go through them all about 4 times. And we're delaying 200 milliseconds between each one. Then we turn them all on at the very end. And then our turn all off and turn all ons right here are looping. So we have 6 of them. We are basically going through the loop and turning them all high. Again, high turns the LEDs off because it's using the Arduino as the drain. So if you put them high, there's nowhere to drain. And then turn all on is the exact opposite. We turn everything on by turning the pins low for all of the lights. And you can see here we're using those arrays again, which makes it very quick to go through and do it. So we have a total of 76 lines for this whole program. Very basic program. But that's what I got this idea on Saturday and found a box and cut it open, and Arduino Leonardo and one of our button boards, soldered 2 buttons on it, and poof, there I have it. I had this this little box right here that did everything that I needed to do. So that was my fun of the weekend. And I have some other stuff still working on with these kind of button boards, and I'll bring them up here and show you. Like I said, we have something that I'm using in here as well. In addition to, I have the same different button boards, but using I2C right here, which is actually what I'm switching back and forth with. Let's see, you see it here? No, not really. You kind of see it like right here. This is what I'm using to actually switch with today. And it's that same button board that I kind of showed you before. If I can pick it up maybe right there. So it's using the same kind of buttons, and these are all ITC, and eventually I'll go through and I'll show you how I did everything inside of it as well with the Arduino and everything. But yeah, that's the same buttons we use for this. These are 15mm buttons. I actually have some 17mm, which I like even better. They're we are going to start redesigning them to 17mm versus 15mm. They just fit your fingers better, I think. Well, that's just my personal opinion. Man, I got big fat fingers. I don't know. But it seems like the standard is typically 15mm, but the 17s have a nicer feel to me. So I consider them more of a luxury switch. But our current designs are using 15s, and we'll probably continue with 15s for most of the products, and then the larger boards will probably go to 17mm because they're a little more expensive, have more features on them. And just the cost of going 17mm is really minimal. We're talking like $1 a button, maybe something like that at most. And maybe saying that much. So very, very minimal as far as the buttons themselves go. All right, so I think that's pretty much it for this week. Let me go through the housekeeping items again. This show is recorded live every Monday night at 9 p.m. Eastern. We'd love to have you in here. We normally have a chat room, although tonight, for some reason, it's broken, and I don't know why. So I'll have to get that fixed. And but we do like you come at 9 p.m. and chat with us in the chat room. We'd love to have you in the chat room. If you want show notes for the show, including the code that I just walked through, it'll be on our show notes at TechZen TV. And the shortcut to get there, if you can go to TechZen TV and you can just click on shows, Let's Make It, and you can see all the episodes and everything. But a shortcut to get to there is just to Let's Make It.tv, and we'll take you right to where you want to go. Also, if you on Facebook, if you go to facebook.com/TechZenTV, we would definitely appreciate a thumbs up and a like in there, and spread it around with some of your friends that are electronics and gadgeteers and stuff like that. We'd love to get them in the show here as well. And if you're on Twitter, you can always tweet us at TechZenTV. Make sure you use the hashtag #Let'sMakeIt. And lastly, if you're watching us on YouTube, please subscribe. It's youtube.com/TechZenTV. However, if you're watching us on downloads, we definitely like that because that's like a consistent thing. You don't got to worry about it. You go sign up, you subscribe, or using iTunes, whatever you're using to watch your podcasts, and it just comes down automatically. You don't have to worry about it. You can take it with you on your phone, in the car. You can take it to work on your iPad. That's what I do. I'll take things to work on the iPad and sit next to me with put my ears in and just listen to podcasts all day long, literally all day long. And I definitely would appreciate that. And remember, Halloween is coming up, and we want to do something for Halloween. So if you have an idea for a project for Halloween, please let us know, and we may try to work it out and get that done. If you've done a project, we'd love to see video and pictures of it. And if you're using it for like trick-or-treat night and you're scaring little kids and stuff walking by, make sure you send us some video of that too. It'd be very cool to show what you can do with Let's Make It type technologies, like putting Arduino in a pumpkin. I don't know what I'm going to do. I'm going to try to do something like that here and see what I can do. If I can get somebody to help me carve the pumpkin or carve it for me, so that's the goal. The artistic part of me doesn't do good at carving pumpkins. It looks like a really nasty pumpkin. But if I can get somebody to help me carve one out, I may try to do something with an Arduino in the pumpkin, and maybe work out some of those details as well. But I'd love for you to help us with the ideas for what you think would be good for Halloween, electronic wise. So, let us know. We definitely appreciate that. Hopefully, Bob's back with us next week. And some of his family emergency stuff's calmed down a little bit, but we do wish him well, and he definitely, if he needs the time to take for his family, that's more important than this show ever can be. So hopefully he's back with us next week, and if not, I'll be doing something solo again. And I should have a smart buttons back by next week, so maybe I'll just show you what I plan on doing tonight. All right, that's it for Let's Make It this week. We'll see you all next week. For show notes for this show, contacts, and more, go to the TechZen.tv website, where you can get show notes for all of our shows. We love to hear from our viewers and listeners. We have an email, a Twitter, and a phone number where you can contact us for each show. For details, visit the TechZen.tv website and get the show details. You can also make a video and upload it somewhere like YouTube or Vimeo, and then just send us a link. You never know, you may see your video in a future show. You can get all of our shows delivered automatically to your favorite device by going to your favorite podcast website like iTunes and subscribing. Each of our shows also has a YouTube channel you can subscribe to get regular updates. Our shows are also available on most internet radio networks like Stitcher and TuneIn Radio. You can also watch and listen to our shows on Xbox, TiVo, and Roku. You can even find us on your Zune.